Hello and welcome all to the pilot episode of Math Proofs. Every week I'll try to prove theorems, formulas, etc. etc. Today I will prove the Pythagorean Theorem. I hope you find this video helpful, and without any further delay, let's begin. The Pythagorean Theorem states that a triangle with sides A, B, C has the following characteristic. A squared plus B squared is equal to C squared. Now, why is this true? Let's look at a geometric approach to this proof. Say we have four identical right triangles. Now let's make a square out of these triangles. What would be the area of the inner square? Notice that the sides of the inner square is the length of B minus the length of A. This is true for all the sides. Thus we can conclude that the area of the inner square is B minus A squared. Let's shift our view towards the triangles. Recall that the area of a triangle is the base times its height divided by 2, or in this case, B times A divided by 2. The area of all four triangles would be the same equation times 4, which reduces to 2AB. Notice that the area of all four triangles is the equivalent of the area of the big square minus the area of the inner square. The sides of the big square is actually the hypotenuse of each triangle. Thus, the area of the big square is actually C squared. So the area of all four triangles is the equivalent of the area of the big square minus the area of the inner square. The rest of the problem is now algebraic. First we're going to FOIL out B minus A squared, which becomes B squared minus 2AB plus A squared. Next, we're going to distribute the negative outside, which transforms the right side to C squared minus B squared plus 2AB minus A squared. Now we're going to subtract 2AB from both sides, so that now it'll become 0 is equal to C squared minus B squared minus A squared. Our last step would be to add B squared and A squared to both sides. So now the equation becomes B squared plus A squared is equal to C squared, which is the same thing as A squared plus B squared is equal to C squared, which completes our proof. If you have any questions, comments, or suggestions, feel free to share. Thank you for watching.